Okay, so today we're going to have a look at inequalities, but we're going to have a look at what happens when you have a negative coefficient in front of x. So there are a couple of different ways in which you might want to do this. I'll show you both methods on the first example, and then you can sort of pick which one you think is best for you. So on the first question, we've got 5 minus 2x is greater than 3. So if we go through method 1, first of all, and that is eliminating the negative 2x by adding 2x to both sides. So if we here add 2x to both sides, we would get 5 is greater than 3 plus 2x. We could then subtract 3 from both sides, and we would get that 2 is greater than 2x. And then if we divide by 2, we would get that 1 is greater than x, or x is less than 1. The other method, which we touched on in the first lesson with regard to having a negative coefficient, is if I write out the question again, 5 minus 2x is greater than 3, is to eliminate this 5 first of all. So if we subtract 5 from both sides, then we've got negative 2x is greater than negative 2. Now remember, to eliminate a negative in an inequality, if we times throughout by minus 1, we have to change the sign. So if I times that by minus 1, I would have 2x on the left-hand side and 2 on the right-hand side, but the sign would have to change. So I've then got 2x is less than 2, and if I divide throughout by 2, I have then got that x is less than 1. And you can see that these two are the same. So both of those methods work. Either eliminate the negative x or eliminate the other values and then swap the sign as necessary. Okay, example 2, we have got 3 minus 3x is less than or equal to 5. So I'm just going to show you method 2 for now. And so in this case, I'm going to need to subtract 3 from both sides, and I've got minus 3x is less than or equal to 2. Now if I divide throughout by 3, I have got that negative x is less than or equal to 2/3. And to eliminate that negative x, I can times throughout by minus 1, so x is therefore greater than or equal to minus 2/3. Okay, question 3, we've got a bracket involved. So the first thing that I would suggest you do here is expand the bracket. So we've got 8 minus 12x is greater than or equal to 4. And then this looks very similar to question 1. So for this one, we'll do similar to method 1, just so that you've got a mixture of methods involved. So that means that in this case, I need to add 12x to both sides to eliminate the minus x. So I've got 8 is greater than or equal to 12x plus 4. Subtract 4 from both sides. And 4 is greater than or equal to 12x, and then if we divide throughout by 12, well, 4 divided by 12 can be simplified to 1/3, so we've got 1/3 is greater than or equal to x. Very last question, which we'll run through, is when you've got two inequalities. So minus 5 is less than or equal to 3 minus 2x, which is less than or equal to 15. Now, the first thing that I'm going to do in this case is similar to method 2, where I'm going to eliminate this 3. So if I subtract 3 from all terms there, I have got minus 8 is less than or equal to minus 2x, which is less than or equal to 12. Now I'm going to divide throughout by 2. So I've got minus 4 is less than or equal to minus x, which is less than or equal to 6. Now, in this case, you are wanting to multiply throughout by minus 1 and change the signs. So if the first thing we do is multiply throughout by minus 1, minus 4 becomes 4, minus x becomes x, and 6 becomes minus 6. Then if we swap the signs, This less than or equal to becomes greater than or equal to, and the same here. And so you can see that the integers have been multiplied by -1, so the sign has changed, and the inequality sign there has changed. And you could also then rewrite this as -6 is less than or equal to x, which is less than or equal to 4. And both of these values here would mean the same thing. So if you can now pause, sort of digest all of that information, look back at the examples if you need to, but have a go at the your turn questions. Come back and we'll just run through those quickly together. Okay, so the your turn questions, if we just quickly run through, I'm not going to show both methods because you may have picked different ones, but we'll just run through so that you've got the answers. So here I'm going to subtract 7 from both sides, so I've got -3x is less than -6. Then if I divide throughout by 3, I've got -x is less than -2. And then if I times by -1 and swap the sign, I've got x is then greater than 2. Example 2, I'm going to do the other method, so I'm going to add 2x first of all. We've got 8 is greater than 2x plus 4. If we subtract 4 from both sides, we've got 4 is greater than 2x. And then if we divide by 2, we have got that 2 is greater than x. Question 3, one with brackets. So if we multiply out the brackets, we've got 20 minus 10x is less than or equal to 6. In this case, I'm going to do like method 2 again, so take away 20, and we've got minus 10x is less than or equal to minus 14. Divide by 10, so minus x is less than or equal to minus 1.4, and then multiply by -1. Swap the sign, so we've got x is greater than or equal to 1.4. Last one here, we've got a double inequality. So the first thing I'll do is subtract 1 from each term there. So we've got 7 is less than or equal to -3x, which is less than or equal to 16. If we divide throughout by 3, I'm going to leave this as a fraction rather than a decimal, so I would there end up with 7 over 3 is less than or equal to -x, which is less than or equal to 16 over 3. And then in this case, if I multiply throughout by -1, we've got -7 over 3 x and -16 over 3, and we swap the signs so that your inequality would look like so, which again we could rewrite as -16 over 3 is less than or equal to x, which is less than or equal to -7 over 3. So that's the end of the video. There are practice questions for you to have a go at, and there are worked solutions at the end, so make sure that you mark your work, and if you have any questions, email me to let me know.